Hey, Physics 151, it's Lipkin here. We're going to talk about and give you some stuff to work on for your combining forces lab or adding vectors lab. At any rate, I wish there was a better way to do this than what we're going to do here, but what we're going to end up doing is me and Matthew, a physics student, are going to basically run the experiment, and you guys are going to tag along by watching this video and look over our shoulder. But what I wanted to start off with was vector 1 was 350 located at 0 degrees. And don't make sure you put hats on top of vectors. And vector 2, it's going to be 450 at 40 degrees. Okay, and so here you can see I've drawn vector 1, and then this angle here is 40 degrees. Okay, now I want you guys to make a scale drawing, and so if you'll come with me over here real quick, we'll see my scale drawing. Okay, where I've made this 3.5 inches long, and then I made this one 4.5 inches long. Okay, and then I measured the distance, or the angle here is 40 degrees. Okay, and now you can see what the answer is about to be. Okay, but by putting the vectors tip to tail like this, and this wasn't to scale. The drawing I just showed you was to scale, and it has to be a scale drawing. But if you put the vectors tip to tail, then I can just measure the length of this line, and that would end up being the magnitude. And then I can just measure using a compass this angle, which will be our resultant angle. Okay, and that's what we're going to do. So the first way of resolving these forces is to do it by graphing, or by drawing, making a precise drawing. Okay, now come on over here, Matthew. Okay, and now we've done the same problem, except that we're going to do it analytically. Okay, so the first vector, it was going off 350 at 0, and I said, and this is my convention, that the x-axis is going to be 0 degrees. So it's going off 350 in the x direction. You notice my little unit vector has a hat on top of it. Okay, and then for vector 2, I have 450 cosine 40. Okay, sorry about that. At any rate, so the vector 1 is 350i, and then we can resolve vector 2 into its component parts, I and j, just by saying the magnitude 450 times the cosine of the angle that goes with it. We said it was at 40 degrees. This will always be in the x direction. And then 450 sine 40 for the j direction. We went ahead and showed how this would be broken into I and j components. Now that I have vector 1 and vector 2 in I and j components, I can add vectors 1 and 2 together, and that's what I just added my I components to get 695i, and there was only one j component, 289. This has given me the resultant vector. Okay, and so now, as of course you guys should know, in order to find the magnitude of the resultant vector, all I have to do is square 695 squared plus 289 squared, and then you take the square root. You know how to do that. At any rate, and now to find the resultant angle, all you have to do is we talked about this before, but here it is. Depending on which quadrant you're in, and of course here we're in quadrant 1, but the function you'll use is tangent your y component over your x component. I'm sorry, inverse tangent, of course. Okay, and you'll always use this. It just depends on which quadrant you're in. Okay, if you're in the second quadrant, you go 180 minus your inverse tan. Y over x is going to stay. If you're in the third quadrant, it would be 180 plus inverse tan. Again, y over x stays the same. And then if you're in the fourth quadrant, you're just going to say negative inverse tangent. Again, y over x. So we use those conventions to be able to talk about where we want this theta to be. At any rate, this first one, 695I plus 289J, is clearly in the first quadrant, so all we have to do is go inverse tangent of 289 divided by 695. When I do that, I come up with 22.6, okay? And now, this is actually especially for this kind of lab, and we're going to show you an example here in just a second. But if I go 180 plus this to find the equilibrium angle, so the equilibrium angle is just 180 plus theta r, you'll notice I come up with 203. Now we're going to come and show you some different practical examples of this, but for right now we're taking a break. Okay, so you'll notice that I did 3.5 inches, not 350, and I did 4.5 inches, not 450. But clearly, I'm scaling by 100 here, right? So by drawing, my scale drawing actually comes up with a magnitude of the resultant, this line from here to here. I think my fingers can hardly stretch that far, but that distance is 7.56 inches. Or 756. Now, of course, you should know the actual magnitude is 752, but this is a rough drawing, or not that rough. I did use a protractor and a ruler, which I want you to make a scale drawing using a protractor and ruler, very much like I did here. You'll see the instructions in the lab handout. Now here, as we come over here, we also have pretty much the exact same thing, and I wish you guys could be here to do this or to see this, but you're just going to have to trust Matthew and I and say, look, here's 350 grams here, and this is at 0 degrees, and then this one is 450 and is at 40 degrees. You can see that in order to make this thing in equilibrium, that I've had to put 750 grams at 202 degrees. At any rate, so this is the same result we just found at the board, and it's the same result we just found graphically. We just call this method the analytical method, and that's what we're going to do. That was stage 1. We'll be back with stage 2. Okay, so here we're going to try to do the force table the way it should be done, which is I'm going to give you 3 forces, and you're going to add them to find the resultant force, and then finally the equilibrium force. So here you'll see that I have 350 placed at 45 degrees. I have 450 placed at, oh my goodness, 303 degrees, and I've got 250 placed at 200 degrees. Okay, so here I'm going to show you the problem on the board. Okay, that way you can make sure you got it all written down correctly. Anyway, 350 at 45 plus 250 at 200 plus 450 at 303. Okay, at this point I would like you to stop this video and do your math and see if you can sum up those vectors, okay? Okay, so in order to sum those vectors, I've got them written down here, and then all you have to do is go the magnitude, which was 350 cosine of the angle, which was 45, okay? And that would be in the x direction, or I hat direction. And then you do the same thing for the y, 350 sine. And actually, you notice that I'm just going cosine, cosine, cosine for the x component, and I'm just going sine, sine, sine for the y component. At any rate, good. And now you can actually see that we've resolved these into their Cartesian coordinates. Now, a quick check is at a 45-degree angle, shouldn't the x and the y component be the same? They should. If they're not, you know you got a problem, but this is a nice check. But at any rate, you also notice that here, when I did sine of 200, that it came up with negative 85, or cosine of 200, negative 234. And that's good as well. Anyway, so just pick a convention and stick with it. At any rate, so we did all that. You can see that here we've put our vectors into Cartesian coordinates. They have i's and j's. And now all I did to find the resultant vector is to add up all the I components. That's where I got 258. And I added up all the j components. That made negative 215. Okay? I find the magnitude by going 258 squared plus 215 squared, find the answer, take the square root. I know it sounded like I just dropped my negative, but remember, this negative would be squared away. There's no such thing as negatives with magnitudes. At any rate, that gives us a magnitude of 336. Now, the resultant angle is a little bit trickier. And here, I'm just not that clever, but I almost always do this. On this resultant angle, I go this way 258 in the positive x direction, and then I go down 215. And so you can see that clearly I'm going to be in the fourth quadrant, and because I'm in that fourth quadrant, that's why I added this negative sign to my inverse tangent function. At any rate, the resultant angle is going to be the negative inverse tangent of the y component, 215 over 258. Again, it looks like I might have dropped my negative, but you have to remember, I've taken care of my own negative, and so it's not appropriate to put that negative in here. At any rate, this ends up giving you a negative 40 degrees for your answer. All right, now once you have the negative or the resultant angle, then to find the equilibrium angle is really quite easy. All you have to do to find the equilibrium angle is just go 180 degrees plus your resultant angle, and here 180 degrees minus 40 would of course give you 140 degrees. And so if Matthew will just follow me over here, we can go back to the force table, okay? And I could put this on 140, and then I'll pull it this way, and then I'll put on that, and of course me and Matthew did set this up before, so it would be all nice and we wouldn't waste our time. But I just put 340 grams on there, and you can see that the table is now balanced. All right. At any rate, so that's a good way of treating forces and how to add vectors. Really, it's easy. If it's in the x direction, it goes with the cosine. If it's in the y direction, it goes with the sine. And it didn't matter that those angles could be bigger than like 90 or 180. Actually, any angle between 0 and 360 would work, wouldn't it? At any rate, so that, again, pick a convention and then stick with that convention. Stay consistent with that convention, and everything will work out fine. All right, I may have one more exercise for you, but that's the end of this one. Okay, so for the last problem, what we're going to do is we're going to sum up 5 vectors. Holy moly. And it's supposed to be hard, but I don't think it really is. Of course, it is tedious. It's long-winded, but I don't think that makes it hard. But anyway, I've given you 5 different vectors. They're all 350 at these different angles, at 60, at 220, at 317, at 270, and then, oh, wow, a negative angle. We know we can have that, no big deal, negative 30. But I would like you to sum up these, find the resultant vector, find the resultant vector's angle, and then last but not least, find the equilibrium angle. When you tell me what the answer is, when you submit your report and say what this is supposed to be, then I will post a video. Hey, Physics 151. So today, I wanted to go over the problem to the vector addition problem that we proposed. At any rate, I'm going to go over the solution now. And so here's the problem. You have 5 vectors. Oh my goodness. Each of them is 350 at these different angles, 60, 220, 317, 270, and negative 30, all those respectively. Oh my goodness. And of course, our process is exactly the same. Okay, so here you can see I've broken them down into their X and Y components using my little I hats and J hats. You break each vector down into its component parts, and then of course you'll sum up all of these parts to come up with the resultant vector, which is of course what I have here in blue. This is the resultant vector. Okay, and then once you have the resultant vector, you need to find the magnitude of the resultant vector, which is of course just the x squared plus the y squared, take the square root. Okay, and now we need to figure out what the resultant angle is. Remember, we have to have our convention, but since this one is, since the resultant is going over this way, 465, and then it's going down 686, we can see that we're clearly in the fourth quadrant, and so we're just going to do the negative inverse tangent of the y component, which was 686, over the x component 465, okay, and of course that equals to negative 56 degrees. All right, at any rate, we always have y over x, so that's good. And then last but not least, we wanted to find the equilibrium angle, because we're going to put this on a force table to see if our numbers make sense or not. So my camera person today is the secretary of the department, Jennifer Henson, so thank you, Jennifer. At any rate, so here we have the force table, and here you can see that, I mean, you are going to kind of have to trust me, but I've got 60, I got 330, 317, 270, and 220. I'm using the outside scale here on all of that. That's something that, you know, you should always do. Be consistent with your scale and then choose it. Now you can see that I also have the resultant here put at, what the heck do I have it put at? It's 124. Oh yeah, that's what it was supposed to be. Okay, notice right now it is not balanced. See if I put this thing, and that is of course because the weight over here is not correct. When I put on this 500, now there is 830 grams over here, and now we can come back up and look, holy moly, the force table is balanced. All right, so that's how you do your force table. That's Jennifer, by the way. Anyway, if you ever have any problems or questions, make sure you either ask me or Jennifer. Jennifer knows everything, by the way. All right, so there's your solution to the force table. Good luck. We'll see you guys around.